Welcome back. Welcome back to Shiksha Jain's training programs on artificial intelligence, data science, a very premier training program being conducted for undergraduate and graduate students. And in today's session, right, we will be discussing a very, very important concept called as principal component analysis. It is widely used in artificial intelligence and machine learning. So, what do you mean by principal component analysis and where it is used? That is an important concept. And in today's session, we will try to demonstrate principal component analysis by implementing it. So, it's titled as project use case on principal component analysis, right? So, under machine learning, right, as part of machine learning projects, what we do in a machine learning project, right? Machine learning is a concept where we try to train our program, which is also called as model. So we train our model using some known data. So we try to train the model and then we use the model for future predictions. So machine learning is a concept wherein we train the model by giving lot of data to it, right? So now principal component analysis plays an important role in machine learning, right? And principal component analysis is a dimensionality reduction technique, right? So principal component analysis, PCA, is a dimensionality reduction technique. So what do you mean by dimensionality reduction technique? What do you mean by dimensionality, right? The point is, in machine learning, right? Suppose we are working on any data set, right? In that data set, we can have variables which are of two types. One is called as dependent variable, another one is called as independent variable. Generally, you will have multiple independent variables, and these independent variables will decide the outcome of the dependent variable, right? So now the point is, if I have a data set, and in that data set, if there are 40 variables, and one variable is the dependent variable, another 39 variables are independent variables. So, do all 39 independent variables influence the final outcome? I really don't know, right? If all 39 variables do not influence the final outcome, do I need to consider all 39 independent variables? I don't know, right? If I consider all 39 independent variables, the variables which do not have any influence on final outcome, by considering them, am I losing the accuracy of my model? I don't know. So all these questions need to be answered. And another question is, by involving all these 39 independent variables, am I not making my model very complex? I don't know. I have to answer all these questions, and solution to this problem or answer to all these questions is principal component analysis. So let us take a deep dive in principal component analysis, and we will try to demonstrate the same thing by taking a use case, by taking a data set, and then finally we will also see the code to implement principal component analysis. So we'll move on. Right. So project PCA. So the agenda is here to tell you what is PCA, what is the purpose of PCA, how PCA is actually implemented, and we also discuss the results. So what is PCA? PCA is a dimensionality reduction technique, right? So that is what I was telling you. I have independent variables and I have dependent variables. So I wanted to study to what extent these independent variables are influencing my final result, my final dependent variables value. So if I can identify which independent variable is important, which independent variable is not important, accordingly, I can reduce the complexity of my data set. I can reduce or I can remove unwanted independent variables, and I can generate and better and accurate machine learning model, right? So understanding PCA. So we'll try to understand PCA in detail with appropriate examples, right? So, if at all you want to implement PCA, these are the 6 steps which you need to follow in order to implement PCA. I repeat, PCA is widely used in every machine learning project because in machine learning, generally the machine learning applications, if you take the data set size itself will be very, very huge, and in that if I have lot of independent variables and I'm studying their impact on the dependent variable, my model becomes very, very complex, and even the model's execution time will also increase. So I cannot minimize the data. So the concept here is, in order to remove the complexity or in order to improve the execution time, we are not going to delete the data records. So minimization, dimensionality reduction doesn't mean that suppose I have 1 lakh records, I will take only 50,000 or 60,000 records. It's not like that. We can't remove the data. So what we do is, suppose I have 1 lakh records and in each record there are 40 columns. 40th column is the dependent variable, 39 are independent variables. So what I can do is to reduce the complexity and to perform better analytics of the data and to generate a better machine learning model. What I will do is I will try to understand whether all these 39 parameters are really useful or not. And by applying principal component analysis, what we will do is we will reduce this 39 independent variables into fewer independent variables. So we reduce the number of columns. But remember, please make a note here, if 39 columns are reduced to 8 or 9 columns, it doesn't mean that we are losing any data. We combine them systematically, we merge them systematically such that the 39 becomes 8 or 9 or 10 columns, but without a single, without any loss in the data, without losing the precision of the data, we are able to reduce the number of columns. So these new columns are called as principal components. So the process of PCA is to convert all these 39 independent variables or whatever you have into fewer number of independent variables called as principal components. So and these principal components are now being used in place of the old values, right? Old 39 columns. So these are the steps. First, you have to standardize the data, right? Then find the covariance matrix, right? Find eigenvalues, compute eigenvectors, generate the principal components, then recast the data with new dimension or new variables. So recasting means I will replace my old variables with new variables. So old variables were 39, then new variables are either 8 or 9, something like that. So my dimensions of my data set was 39 or 40 rows into 1 lakh columns. Now it will become 8 rows into 1 lakh, 8 columns into 1 lakh rows. So the dimensions of the data set are reduced, minimized without losing any precision of the data, without losing any value of the data. We could minimize the data set. And if I can minimize the data set, if I can reduce the dimensions of the data set, then I can develop a better machine learning model, which is not just fast, it will be more accurate as well, right? So let us try to understand these steps in detail, right? Look at this data. This is a data set. We are trying to implement PCA, right? So what was step one? Step one was to standardize the data. So what do you mean by standardizing the data? Principal component analysis, PCA, is a mathematical algorithm. It's a mathematical technique. You might have seen in the previous slide, I was talking about eigenvalues, I was talking about covariance matrix, and followed by eigenvectors. So it is pure math. Now, suppose in my data set, if I have some columns in which we do not have any math non-numerical values if I have, then I can't use that non-numerical data. I can't use non-numerical data to do some analytics or to apply any mathematical formulas. So if it is non-numeric, if it is a string, I can't apply any mathematical functions on it. So what we have to do is we have to make sure that the data set should not contain any non-numeric data. For example, if there is some non-numeric data, then you have to somehow convert it into numeric form. If you look at this data set, let me explain you what is this data set, right? In this data set, we have around 13 to 14 columns. One is called as type, one is called as fixed acidic levels, volatile acidic levels, residuals in that wine. So this is a data set which we have taken from Kaggle. My dear friends, Kaggle is a famous repository of data sets and it is a trusted repository. So if at all you are developing machine learning algorithms and you need data set, you can always visit Kaggle and you can get the data sets from there, right? And another famous repository is UCI repository. And suppose if you are part of India, in India, Indian government has got a website called as data.gov.in. Lot of data from government data, lot of data collected by government of India from various departments like social welfare department, health department, right? All these data sets are also available in data.gov.in. So if you are a person sitting in India, you can use this website to download data sets from Government of India. So there is one data set called as wine.csv. CSV means comma separated value. It is an Excel sheet, right? So what is this wine.csv data set? Is this wine.csv data set has got one column called as quality of the wine. If you look at that one, this is the last column which is highlighted using yellow color, right? So this one, see the mouse pointer, this column is called as quality of the wine. So if you look at the values of that quality, there are values like 6, 5, 7, 8, 9, like that. So each number represents what kind of wine it is, what kind of quality the wine has got. And these remaining columns, if you look at, these are all the parameters which will influence the quality of the wine. And if you look at this data set, I recommend you to download the data set freely from Kaggle website, right? You can simply go to Google and type wine.csv, it gets downloaded. Now, if you look at this data set, there are around 50,000 plus records in this data set. So this is not a small data set. There are 50,000 plus rows or records in this data set. And if you observe how many columns are there, so type is one column, fixed acidic value, volatile acidic value, what is the content of citric acid in that wine, how much residuals are there, how much percentage of chlorides are there, sulfate percentage, right? What is the density of that wine? What is the pH value of that wine? How much percentage of alcohol is there? All these things, right? All these things are going to influence the quality of wine. Now, I really don't know out of these 12 or 13 parameters, which one is more important. Like percentage of alcohol will decide the quality of wine, and percentage of pH value or the pH value may not have that much influence on the quality of wine. I don't know, but what I can tell you confidently is out of all these 12, 11 or 12 parameters, all 12 parameters will not have same amount of influence on the output. What is my output or outcome? Quality of wine. So majorly quality of wine may depend on amount of alcohol in it and what is the acidic percentage in that particular wine. So maybe three or four attributes or columns will have more influence than other columns may have less influence. There may be some columns which may not have any influence on the quality of wine also. So my point here is, can I reduce this 11 or 12 columns into 3 or 4 columns? If I can do this, then what will happen? My number of records can't be reduced. My number of records will be 50,000 plus and they will remain like that. But number of columns, instead of 13 columns, if I can make it to 4 or 5 columns, then the complexity or the dimensions of the data set are reduced. And in the beginning I told you what is PCA. PCA is a dimensionality reduction technique. So our objective of PCA is to reduce the number of columns. Now the interesting point is, in the process of reducing the number of columns, right, are we losing any data? Is it going to affect my output? Suppose 11 columns are there, I want to make it 2 columns, 1 and 2. Then obviously everyone will get a question, sir, out of 11 columns, if you reduce them to 2 columns, are we not losing the data? And if at all the machine learning model developed using these 2 columns, don't you think it will give me inaccurate prediction? So this is a very valid question which can come in PCA. But the point here is, the very important point is, I am not going to straight away remove any one of the column. Like for example, there are 11 columns in this data set. I am not going to, since I told you alcohol presence, a percentage of alcohol is very important. Don't think like I'm going to take alcohol column, then sulfates column, then density column, and I'm straight away removing remaining 9 columns. No sir, PCA's percentage is purpose is not to simply remove the number of existing columns. No, that is not the purpose of PCA. If I'm straight away removing number of columns, then there is no logic in it. There is no valid reasoning also. So what we do is, if I have 11 attributes which are independent variables and 12th one is my dependent variable, so what I will do is, first of all, I'll make sure all my 11 independent variables data is in numeric form. If they are not in numeric form, I'll convert them into numeric form. Then what we will do is, we will standardize the data. Standardization means, what do you mean by standardization? We will convert the data into a form which is, between 0 and 1, so that my calculations will become easy. So I will standardize the data first. Now what I will do is, this 11 columns which are called as independent variables, what we will do is, we will construct a covariance matrix on all these 11 columns. So it will become a 11 by 11 matrix. So we will construct the covariance matrix. So first step, standardize the data. Second step, you will construct a covariance matrix, right? So let us see the math behind PCA. So what is the formula for standardization? For on every column, I will apply this, sir. So X is my column 1. Let us assume on every column, I will apply this formula. So this data set, if you see, let me show you the data set again. Suppose this is a column called as fixed acidic value. There are values like 7, 6.3, 8.1, 7.2, like that. So what I will do under standardization, x minus mean of x. You know what is mean? Mean means average. So x minus mean of x divided by standard deviation of x. So by applying this formula, what will happen to x? All the values of x gets standardized. X value will be standardized. So this formula, called as standardizing the data, will be applied on all columns of the data set, my dear friends. All 11 independent variables. If you have 39 independent variables, you apply this on all 39 independent variables, right? So step one is standardization. Now, how do I find covariance matrix? What is the formula for covariance matrix? So if I have 11 columns, my dear friends, 11 independent variables, I will construct a covariance matrix of size 11 by 11, right? And the formula for covariance matrix is sigma of xi minus x mean. This x bar is nothing but average, sir, mean. So sigma of xi minus x bar into yi minus y bar divided by n, right? So this is basic math which we have studied probably in our schooling also. So I will find covariance. I will find covariance of 11 by if I have 11 independent variables, first I'll standardize all the values of these 11 independent variables. Then I will find covariance of 11 by 11. So covariance of, suppose if I have two variables x comma y, what I will get in covariance? 2 by 2 matrix I will get. So covariance of x comma x I will find covariance of x comma y, covariance of y comma x, and covariance of y comma y. Like that, for two variables, I'll get four values. For 2 by 2 matrix, I will get. And if I have 11 variables, I will get 11 by 11 matrix. So that is covariance, right? Now, once the covariance matrix is found, right, let us imagine the covariance matrix is represented as S. Then eigenvalue is computed using a formula determinant of S minus lambda I is equal to 0, right? It's a simple mathematical equation to be solved, right? And we can find the value of lambda. Lambda is the eigenvalue, sir. So S is covariance matrix. I is identity matrix. So you know very well what is identity matrix. Identity matrix is, suppose if it is a 2 by 2 matrix, my values are 1, 0, 0, 1. So I will solve this mathematical equation S minus lambda I equal to 0 to find the value of lambda, right? Since it's a mathematical equation, since it's a normal expression, right? When we find determinant, we will obviously get two values, because when I solve it, I will get you. I hope you remember the formula also, right? Minus x plus or minus square root of b square minus 4ac minus b plus or minus square root of b square minus 4ac divided by 2a, right? So when I say plus or minus, I'll be getting two values of lambda. Which one is bigger? That value we have to take. So eigenvalues, basically, eigenvalue purpose is to extract the relationship between the variables. So we are trying to minimize the number of variables, right, by creating new variables, and these new variables are actually created with proper combination of existing variables. So what will happen in the final outcome is, suppose I have 11 independent variables. These 11 independent variables, I can convert it into two principal components or three principal components or four principal components based on eigenvalues and eigenvectors, right? And what eigenvector is, it is constructed by combining, right, appropriate proportion of the remaining independent variables. So after finding eigenvalues, eigenvector is computed using the formula S minus lambda I into ui is equal to 0, right? So when I solve this, I will get the eigenvectors, right? Then we normalize the eigenvectors, right? So normalization will be done so that the value fits between 0 and 1 again. So then we perform the dot product between our eigenvector and these independent variables to generate new principal components. So perform the dot product between eigenvector and variables to generate principal components. So these four steps, if I convert them into a program, right, that itself is implementation of PCA, right? So PCA, what is the summary? PCA helps in creating new dimensions of data. So friends, this is an important observation, right? Just to make my data set simple, I am not straight away removing any columns from the data set. Rather, by using all these columns, by studying the mathematical bonding between all these values, I am trying to construct new components, new columns, right, in which these columns which were existing previously, they are appropriately combined, right? If let us say alcohol is one column, it has got more influence on outcome, then the proportion or contribution of alcohol will be more than the contribution of pH or contribution of density in these new components. So new components are created by combining all these 11 components, wherein each component which is more important will have more weightage like that. So PCA helps you in creating the new dimensions of data which are more effective than original variables. So this is the advantage of PCA. So please don't think that we have reduced the number of columns from 11, I bought it to 2 or 3. It doesn't mean that I'm losing some accuracy of my data, or maybe I'm losing some important parts of data. It's not like that. So PCA helps you in creating new dimensions of data, new columns of data, which are more effective than the original variables and are created from original variables only, and they also offer better accuracy in the data analysis. So that's the reason PCA is very, very important. So it is not just reducing the dimensionality of the data set, it also offers you a better representation of data, and better representation of data will obviously lead to better accuracy of your model. Right. So I think PCA, fair enough, it's very clear, it's very simple also, right? And we will see how to implement PCA, right? Using Python, right? We will just see the code. Friends, I'm using Google Colab, right? I hope you are aware of Google Colab. So it's a Google's cloud platform to execute your Python programs. So I'll be using Google Colab, and I'll try to explain you the code as well. Increase the font size so that it will be clear. So implementation of PCA, right? So friends, I'm importing some libraries. NumPy is a library which I hope you are aware of it, to do some numerical operations, to do some mathematical calculations on data. I'll be using this library called as NumPy. And matplotlib is to plot some charts and graphs on the screen, means whatever output I have generated, if I wanted to plot it, I'll be using this matplotlib.pyplot package of matplotlib library. Similarly, for data pre-processing, to do some operations on data, like how do you standardize the data, doing some missing value treatment and outlier management, we use some of the built-in functions which are available in pandas. And to load data set also, we use a function which is called as read underscore csv, present inside pandas, right? So step one, import the required libraries, which we have done. Step two is importing or loading the data set. So friends, data set is equal to pd.read underscore csv. I am loading this wine.csv data set, right? So wine.csv gets loaded. Please note this wine.csv, the path which you are giving to load the data set, if it is not given properly, the data set will not be loaded. Suppose if you are using Google Colab, so what you have to do is, suppose you have downloaded the data set from Kaggle, it is available in your C drive, D drive, or in your downloads folder, right? You have to upload it to Google Colab, and that can be done, right? I'll show you here. So there is something called as sample data, right? There are three dots, click on them. There is an option called as upload. So by clicking this upload option, wherever your data set is available, you can please go to that location, and you can try to download or upload the data set. See, sorry, not download, upload. So simply click on this wine.csv and click on open button. It gets uploaded. I am not doing it because I have already uploaded. So this is just for your reference. You can see this. Fine. So see this symbol. This is the symbol, files symbol. You can click on this one, and in under sample data, upload the wine.csv file. So now since the data is uploaded, I can use this one, right? So for reference, if you want, once again, I'll show you because this is important, right? Downloads. And one more important point, if this Google Colab is if this Google Colab is turned on now, or next time when I load it, all the data sets or files which are available will be deleted. So whenever I use Google Colab, every time it is important that I should load the data again. So first check whether wine.csv is available or not. See here, wine.csv is available, right? Now see here, data set is equal to data set drop NA. So data set represents the wine.csv file which is already loaded now. Drop NA is a function which will remove the records which contains null values. If there are some null values in my data set, I just want to remove those records, and I'm doing it by using drop NA function, right, which is there under pandas library. Now since I'm working on principal component analysis, now I have two parts in it. All my independent variables is one set and dependent variable is another part. So what I am doing is I am keeping all my 0 to 11, all my 11 independent variables will go to a variable called as X, capital X, and Y, which is my dependent variable, quality of wine, the last column, I am storing it in a variable called as Y. So Y contains what? Only one variable, dependent variable. X contains what? X contains all my independent variables, right? So now I bought my data set into Python program. In that, 11 columns are in X and my dependent variable is in Y. So I have separated them. Now there is a package called as sklearn, right? Sklearn is again a Python library which is readily available in every Python program. So from sklearn underscore models dot model selection, I'm importing something called as train underscore test underscore split. So you all know, if you are into machine learning, you know very well, we will not develop a machine learning model by using complete data set. We use 70% or 75% or 80% of the data for training our model, and we use the remaining 20 or 25% of data to test our model, because without testing the model I will not come to know what is the accuracy of my model, and I can't test the model on new unknown data. To find accuracy, what should I do? I should test my model on the known data, right? So out of data set, suppose I have 10 records, I will give only 7 records to training. Once the model is developed, I will test the model on remaining 3 records so that I can check what is the expected answer, what is the generated answer. So in all these 3 cases, what my model has done, how many times it was giving me correct answer, how many times it was giving me wrong answer. So in order to test or measure the accuracy of model, I need to test the model on known data itself. So what we do, the general combination of training data and testing data is either 70% training, 30% test data, or 75% training data, 25% test data, or 80% training data, 20% test data. So these are three generally used combinations of training and test data. So we are going to split our data into training data and split test data using a function called as train underscore test underscore split. And if you see test size is 0.2, it means 20% is my testing data and 80% is training data, right? So friends, I'll be doing pre-processing of my data, right? So whatever steps we have seen, now we are going to implement them. So loading of data set is done. Then we have After loading, what we have done, we have splitted the data, we have removed unwanted records like null values were there. Now I am doing the standard scalar standardization. I have shown you what is standardization. Now how do I do it in Python? Again, in sklearn there is a package called as module called as pre-processing module. In that there is a function called as standard scalar. I am simply calling that function standard scalar, and I'm storing that function in a variable called as sc and I'm applying it on my training data as well as test data, because entire data set has to be standardized, right? But now data set is divided into two parts, training and test data. I am applying this standardization function on both training and test data. What is standardization, right? Just now in the beginning of the video we have seen. Now apply the PCA function on training and test set of X component. What is X? X contains all my 11 independent variables. So how do I apply PCA? See here, from sklearn.decomposition. Decomposition is a module. There is a function called as PCA. Simply call this function PCA. See here, PCA of n underscore components means number of components is equal to. You can tell how many components you want, right? What do you mean by components here? Those 11 independent variables were there in that X, capital X, right? Now I want to convert them into two principal components, means 11 variables dimensions will become two dimensions now. So this n underscore components, you can give the value, my dear friends. You can give it 2, 3 or 4, it's your choice. Now 11 independent variables are combined appropriately, are merged appropriately into two components. If I write number of components equal to 3, I'll get 3 components, but I am making it 2. So it is in your hand, and PCA is a ready-made function which is available. You simply apply that PCA function and tell how many components you want. So principal component 1, principal component 2, only two components you are going to get. Means your data set which had 11 columns and one dependent variable, output variable called as quality, will be converted into principal component 1, principal component 2, only two independent variables, and one output variable called as quality of wine. So quality of wine will be now decided by PC1 and PC2. So what is PC1 and PC2? PC1 is one new variable called as principal component 1. PC2 is also another new variable called as principal component 2, and both are created by using appropriately all these 11 independent variables. So that is how I reduced the dimensions of my data set, and that's the reason PCA is called as dimensionality reduction technique, right? So this PCA function itself will take care of all those steps. What steps we have seen? Standardization I have done using standard scalar function, but remaining functions, finding covariance matrix of all these 11 independent variables, finding the eigenvalues and eigenvectors, then finally normalize the eigenvectors. Normalized eigenvectors will be multiplied, a dot product operation is done between the normalized eigenvector and my original variables. So what will happen? I'll be getting these fewer number of components called as PC1 and PC2. So all these remaining three steps are automatically done using PCA function. But what exactly PCA function should do? We should know the math behind it. That's the reason we have discussed all those steps prior to seeing the code, right? So PCA function is applied. Now just fit it. PCA function object is created. Small letters PCA represents the PCA object which was created, and the parameter or the number of components mentioned are 2. So I'm just fitting the model PCA.fit on training data as well as test data, right? Now once the model is available, I would like to apply logistic regression. I would like to apply logistic regression on my new data set. So see here, so there are three parts in the code, my dear friends. One is you have to load the data and pre-process the data set, generate that standard scalar and PCA functions, apply them. Once the PCA function is applied, now you are going to test it on your data set. So on X train and Y train, I am going to fit my logistic regression model, right? And I want to predict, I want to do a logistic regression, I want to do a prediction on my test data. Not just a prediction, I just want to see what is the accuracy of my model, how my model performs using confusion matrix. I'm going to print that also, right? So finally, as I told you, matplotlib can be used to plot the outcome so that I can give you some graphical representation of my output. So when I run this program, right, this is the output which was generated, right? So these are the principal components, right? If you observe this carefully, this horizontal line x-axis represent PC1 and vertical line Y represents PC2. So actually PC1 and PC2 will contain all features of 11 independent variables. So all features of 11 independent variables were merged together such that we don't lose any data and we get only fewer number of input variables or independent variables. So 11 became 2 and I did not lose any data, and on by using these new components I'll be doing my data analytics on that outcome variable called as quality of wine. So how 11 independent variables are converted into two independent variables, two principal components called as PC1 and PC2, that implementation can be seen here. So PCA is very, very important in machine learning. The reason is in most of the real-time data sets, my dear friends, what will happen is in most of the real-time data sets, the number of records will be in terms of lakhs, right? You may have 10 lakh records, 15 lakh records in your data set. And on those records, you will have again 30, 40 columns in each record. So processing this much amount of data becomes very complex, right? So processing this much data becomes very complex. And what will happen is at times the number of parameters which are not really so important, they are also being used in data analytics. So what I want, I don't want to use such components, right? I don't want to use such components, and I can avoid them. So there should be a mathematical reasoning. I can't blindly remove column one, column two, and I can't say I have reduced the number of dimensions. There should be a math behind it. There should be a mathematical reasoning behind it. So if you see, by using principal component analysis, what we are doing is we are using very old and very well-known concepts of math called as eigenvalues and eigenvectors, which will help you in order to study the mathematical relationship between the values and their appropriate combination. So using eigenvector, I can extract the proportion of data which I need from each column. So more, if a column has got more influence on outcome, that column's contribution will be more in my new principal component. If a column's influence on the outcome is very less, that column's contribution in my new principal component will also be very less. Like that, with a scientific reasoning, we are able to reduce 11 independent variables into two independent variables. So with 100% confidence, we can tell like we did not lose any data. We are not compromising on precision of data, but still we are able to reduce the number of dimensions or number of columns into fewer number of columns. So the new columns are called as principal components. So my old data set with 11 columns and one outcome variable will be replaced with two columns and one outcome variable. So if you remember in the last step, I said recast the data set with new values. So our data set is now transformed into a new data set with only three variables. One is PC1, PC2, and outcome quality of the wine variable. So this is what is principal component analysis, right? I hope you understood the importance of principal component analysis. And principal component analysis is applied almost in every machine learning project in order to reduce the dimensions and it's a very popularly used dimensionality reduction technique. So, friends, hope you understood what is PCA, what is the importance of PCA, how PCA is implemented, what is the math behind PCA, and how exactly the principal components are created, and finally, how PCA is able to do dimensionality reduction on your data set and helps you in developing a more accurate and more quick and faster machine learning algorithms. So I wish you enjoyed this video, you understood importance of PCA, right? We'll be coming up with more such interesting videos and project use cases in the future in the field of data science, AI, and all other emerging technologies. Thank you.